Good morning everyone, this is Shivteja and my roll number was 1247 and today I am going to explain about uh, recurrence relations and their characteristic equations. Let the initial quadratic equation be r square minus c1r minus c2 equal to 0. Here the characteristic roots will be r1 and r2. It consists of three cases. For case 1, if the roots are real and distinct, then we use the formula an equal to alpha 1 r1 power n plus alpha 2 r2 power n. Here alpha 1 and alpha 2 arbitrary constants. Case 2, if the roots are real and equal, then we use an equal to alpha 1 plus alpha 2n whole whole r power n. Here where alpha 1 and alpha 2 are arbitrary constants. If the roots are complex numbers, then an equal to r power n of r alpha 1 cos n theta plus alpha 2 sin n theta. We can see detail by seeing an example. Solve the recurrence relation an equal to 5 a n minus 1 minus 6 a n minus 2. Let us find the order of this equation. Let us consider this an minus 2 equal to 0, n minus 2 equal to 0. Here order will be n equal to 2 and also given that a naught equal to 1 and a1 equal to 0. We know that given characteristic equation is r square minus 5r plus 6 equal to 0, because by transferring this to this side we can get this. By solving the quadratic equation we can find r1 and r2. Here r1 is 2 and r2 is equal to 3. We know that the characteristic equation an equal to alpha 1 2 power n plus alpha 2 into 3 power n. We know that a naught equal to 1 and a1 equal to 0. These are the given values. If you substitute in this formula n initially n equal to 0, then a naught equal to alpha 1 plus alpha 2. By placing n value 0 and given a naught value equal to 1, we can get this 2 alpha 1 plus 3 alpha 2 equal to 0. And by considering n equal to 1, we can get 2 alpha 1 plus 3 alpha 2 equal to a1, 2 alpha 1 plus 3 alpha 2 equal to 2. By solving this we can get an equation, and by solving this eliminate and substitute method we can get alpha 1 equal to 3 and alpha 2 equal to minus 2. These are the arbitrary constants. We know that the particular solution formula by using alpha 1 and alpha 2, an equal to 3 into 2 power n minus 2 into 3 power n. When coming to graph definitions, initial graph means it consists of edges and a set of edges and vertices. When coming to the main definitions of the graph, director graph. A director graph means it consists of a direction. Each edge must consist a direction. This is the example. Every edge consists of some direction. When coming to undirected graph, it does not have any directions. The definition is the same. If consider a graph G is said to be undirected when no edges of the graph has a direction. When coming to mixed graph consists of both directed graph and undirected graph. Let us consider this example. Here from A to B there is an edge which consists of a direction, but from A to D it does not consist of any direction. That means it is mixed of both direction and undirection. That means it is mixed graph. That's why it is called as mixed graph. When coming to symmetric directed graph means in which all the edges are bidirected. That means it comes to one node and it leaves to another node. That means it is bidirected. It is both directed. When consider this example, here A to B, that means it goes to from A to edge goes to B, and B to there is an edge between B to A. Thank you one and all for giving me this opportunity.